Hello, this is the first video for online geometry this year. I'm Mr. Hall. I'll be your teacher. I just wanted to do a quick overview of what the class is like. You don't have to read the whole syllabus. You can if you want, but basically, the main thing you have to do is just check into Google Classroom because that's where everything's going to be posted. So that's where quizzes will be, tests. Every quiz will have a practice quiz. Every test will have a practice test. This is where your assignments will get posted. You do have to check in every day. That's important for attendance. So that's kind of the school's policy on it. So you're going to see on Classroom this daily check-ins thing. So it's going to always going to be a super quick question, something you can do in 10, 20 seconds. It might occasionally be a very simple math question, something kind of related to what we're doing, but it'll always be really straightforward and quick. The first one is just going to ask you, tell me something cool you did this summer. So really, this is just for the school to take attendance. So you got to do this every day before noon. So for this class, you don't have to be logged in at an exact time, but you do have to check in online once a day. Now, as far as work goes, your problem sets, your homework assignments, those are only going to be due about like once a week. So you're not going to have to submit work every single day. You'll have to kind of manage your time and spread out your work over the course of the week, and then get it submitted. So there's already a video, or there's going to be a video posted about how to, you're going to be doing work by hand, and then I need you to scan it to a PDF file and submit it through Google Classroom. And so if you have never done that before, I made a short video. It's like 4 minutes long. It shows you step by step how to do it. It's actually pretty simple. You just get an app on your phone. You take pictures of your work. It converts it to a PDF, and then you can submit it. So please don't send just pictures. The files will be too big. It's not going to be manageable. So it's a good skill to have just generally, is because PDFs are kind of the sort of the default format of the business world. And so you definitely it's good to know how to work with them and use them. So it's something you'll be able to use beyond this math class. So, okay. So anyway, getting into it, each week or so, you're going to have to complete a portion of a problem set. For this first week, we're going to do problem set 0. It's a very quick review that I made. It's just 6 questions. We're going to go through them together, just kind of knock them all out, and then this will help me make sure that you know how to scan your work and send it in. That being said, your problem sets, I will post them as PDFs, but and ideally, it'll make your life easier if you can print them out and work on them, because there's diagrams and stuff. But I've already printed out a bunch. You can come by the school. I think they're doing it Wednesday afternoon. You can come by the school and pick them up. So if you or a parent or guardian, whoever, can come by the school and grab them, then it'll save you a lot of work, and it'll be easier for me for grading purposes if you can just do the work on the little packets that I give you. So it'll be good because you won't have to copy questions. You won't have to copy diagrams. You can just do the work on the paper. So basically, I mean, imagine you had, this right in front of you already, and you just had to do your work below the problem. So I hope that makes sense. It's designed to make your life and my life easier, and just help make things go more smoothly. So I think that's it as far as logistics go. Yeah, and then your quizzes will be on here on Google. There'll be Google Forms. Every quiz, I'm going to post a practice quiz, and you can get bonus points on your quiz by just doing the practice quiz. I'll probably post a video where I go through most of the questions, so you can kind of just do the problems with me in a sense, and get some extra credit for doing that. So, and then if you have questions on the material, you can get a hold of me, email me. I'll be at the school. Second period is the second period of the day I have devoted to just being there for answering your guys' questions. So you can call me, you can call the school, you can email me, we can do a Zoom meet or Google Meet. Or if you want, you could come by the school and we could meet in person. But um, so just, I'm open during that time, but you can email me any time of day and I'll get back to you as quickly as I can. So, all right. I think that covers all just the, sort of the logistics of how the class works. So just let me know if you have any questions. Let's get into it here. So your first problem set, this is a mini version of what these videos are going to be like. So in the video, we're going to have some problems to work on. That'll be your problem set or a practice quiz, whatever. And I'll kind of work through today. I'm going to go through every single problem. Other days, I don't know, I might do half the problems and then you have to figure out the rest of the problems on your own. So today we're going to do all of these problems together. So you just need to kind of follow along, ask yourself, does this all make sense? This should all be review, hopefully, for the most part. Should be all stuff you've seen before. So if not, let me know if you want some additional practice on this stuff. If we do a problem and you're like, oh, I don't never seen that before, let me know. We can practice it. But anyway, this stuff is going to be covered on problem set number 1. So hopefully this will give you a good sense of kind of what we're doing in the first problem set. So, okay, first thing, find x. We got a triangle here. So notice it's a right triangle. That's what that little symbol means. That little box shaped thing down there means it's a right triangle, means that's 90 degrees. So that's worth noting. And I want to find x. Now, throughout this class, Google is your friend. So if you're stuck, I'm going to cover everything you have to know. I'm going to cover in these videos. So you shouldn't really have to do much researching on your own. I hopefully will just cover everything. But let's say, you missed something in the video or you just need more information on it. Google's your friend. So I can very easily Google. It's amazing how you can phrase searches nowadays. I can say, how to find the missing side of a right triangle. I mean, you can phrase it like an actual question. And you can see that Google is pointing me towards some resources about the Pythagorean theorem. I could then do further searches. What is the Pythagorean theorem? I'm just showing this to you so you're encouraged to find resources on your own if you want. So there's no rule against Googling stuff. So okay, so here you go. Here's a triangle. Let's say I didn't know the Pythagorean theorem and I just spent a few minutes looking it up. It would have showed me that the formula here is short leg squared plus the other leg squared equals the hypotenuse squared. Another thing you might want for this class, if you can get a calculator, that'd be awesome. This is a graphing calculator. It's probably overkill for this class. You can just go get I would recommend getting like a scientific one. They might run you $10, $20. Or if you don't want to get a calculator, find something online that works for you. I like Desmos. And it's a graph. It does graphs and stuff, but you can use it really easily for stuff like this. What is 4 squared? Oh yeah, it's 16. What is 4 squared plus 8 squared? It's 80, right? So you got 16 and 64. If you add that up, you get 80. All right. And so now, what number squared makes 80? Well, that is the square root of 80. Okay. Now, we could stop there. We could get a decimal. So what's the square root of 80? It's roughly 8.94. So, but in this class, we're going to be more we're going to use what they call the exact solution. So this one you may not have seen before. Maybe you have. The technique is looks like this. So I say, well, square root of 80. Are there any perfect squares that are factors of 80? The answer is yes. By perfect squares, I mean 1, 4, 9, 16, 25, 36, 49, 64, any number squared. So 80 is 16 times 5. Now, notice it's still under the radical. And now, what's the square root of 16? Well, it's 4. And what's the square root of 5? The square root of 5 is called root 5. And so this is what they call the exact solution. If that confused you, don't worry too much about it. We're going to practice it. But you definitely want to make sure you're comfortable with going from the triangle to setting up the Pythagorean theorem to then getting an answer. So if you can get to here, you're good for now. You're doing fine. One more example would be, this time notice the hypotenuse, the long side, the longest side, is known, whereas before it was unknown. So let's find it. So same setup as before. You go short leg squared plus other leg squared equals hypotenuse squared. Notice this time the x is here on the left side, not by itself. So that's 49, that's 25. Okay, so what we're going to do is subtract 25 from both sides, right? So x squared has to equal, so 49 minus 25 is 24. And so x is the square root of 24, which, if you think about it, the square root of 25 is 5, so the square root of 24 has got to be just a little bit less than 5. We can confirm with the computer what's the square root of 24. As you can see, a little bit less than 5. If we apply that same method from before, it would look like this. 24 is 4 times 6. So we would write the answer as 2 root 6. Sorry, I'm getting a little crammed down there, but this is the, again, exact answer, or the simplified exact answer. This is also exact. This is the simplified version of that number. Again, don't stress if that last step was confusing. If you're good with getting to root 24, you're good. Okay, next, we're going to be dealing with this a lot. This idea of being halfway between two things. So in geometry, a lot of times you have like a segment, and then you have information about the two endpoints, and you want to know about what's halfway between. So this is on a number line. So say on a number line, you had 9 and you had 43. And you were wondering what number is halfway between. Okay? There's a few ways to go about solving a question like this. I'll just go over 2 really quick. So one method would be take the total distance. So what's the total distance here between 9 and 43? If you subtract the numbers, you get the distance. So the distance would be 43 minus 9, which is 34. Again, use a calculator. If, the class is not really about doing arithmetic, it's about doing geometry. So if you gotta grab your calculator, no worries, it's all good. So the distance between these is 34. So I could say, okay, well, it's half the distance then. So half the distance, 34 divided by 2, is 17. So I could add 17 onto my number here to get the, where I want to end up. So let's add 17 onto my 9, and we get 26. Okay? So then the question is that correct? Right? Well, 26, if you subtract those, you'd get 17. And if you subtracted those, you would also get 17. So that means that 26 is halfway between. All right? Now, if that was confusing, well, if you're confused, you should try to make an effort to make sense of it, to try to understand that logical process. But also know that there's a formula. You've probably heard of it. It's called average. So halfway between 9 and 43, you can just go 9 plus 43 and then divide it by 2. So 9 plus 43 is 52. 52 divided by 2 is 26. Okay? So, yeah, there you go. There's a fast way to get the answer. All right? Another one. 37 is halfway between 61 and what number? So this one looks kind of like this. Here's my number line. Here's 61. Here's 37. I wrote the wrong number. Sorry. 37. And now the question, though, is what number is on the left, right? So 37 is, so we know the midpoint, 37, and we know one of the endpoints, 61, but we don't know the other one. So here you could come back to this idea and do a formulaic approach, but then you're going to be doing some algebra, which is fine. But if you're wondering, it would look like this. You'd say x plus 61 divided by 2, that's the average, and you'd set that equal to 37, and then you'd solve that for x. So if you do that, you would multiply both sides by 2 and then subtract 61, and so you'd get your answer that way. What do you get there? You'd get 74 minus 61 is 13. Now, I found that most of my students in geometry, they tend not to want to do it that way. They want to avoid the algebra. So all they do, it's a pretty nifty approach, is they use this idea. The first one we talked about. They say, how far is that? How far from 37 to 61? Just subtract the numbers. So again, if you subtract those, it tells you the distance. So 61 minus 37 would be 24. And they say, well, then I just got to go to the left 24. And they say, okay, start at 37, subtract 24, and that gets you 13, the answer. Okay? So as you can see, again, there's two different ways you can kind of do the work and end up with the same correct answer. Okay? Also, just when we're doing this together, make sure you show your work. If you just write 13 and no other work, I can't give you credit for it. So make sure you're already putting in the time to watch the video. Well, I guess you are if you're listening to this, but take the extra time to show the work and earn full credit. So, okay, last two questions. Solve for x. This is just basic like algebra. So can you apply algebra to solve an equation? This comes up a lot in geometry because a lot of times you'll have, this angle is the same size as this angle. And so you end up setting up an equation and then doing some algebra to figure out the problem. So long story short, to solve this, you have two x terms showing up. We would like to have only one x show up. So the idea here would be subtract 2x from both sides of the equation. So if I take away 2x from this side, I end up with 3. And if I take 2x away from this side, I have 6x's minus 2x's makes 4x's. Now what? Well, I don't really want the 17 to be here anymore. So I'm going to add 17 to both sides. And I have 20 equals 4 times x. So now, since it's 4 times x, I want to undo that. I'm going to divide both sides by 4. And there's my answer. X turns out to be 5. How can I check my answer? Well, if I plug 5 back into the equation, it would read 2 times 5, 10, plus 3, so that's 13, equals, so let's plug 5 into the right side as well, 6 times 5, 30. 30 minus 17 is also 13. Is 13 equal to 13? Yes, it is. So we've just checked our answer. We know that it's correct. Last question. Parentheses over here. So you have to, your first step, well, you don't have to, but it's, in this case, it's the easiest way to do it. You want to distribute the multiplication. So 2 times x, and then 2 times 10. All right. Now, same procedure as before. So it's pretty much the same setup. Subtract 2x from both sides. This time there were more x's on the left side than the right side. So this time around, I'm going to end up with my x's on the left-hand side. Could I have done it the other way? Could I have subtracted 5x from both sides? Sure, totally fine. I just would have ended up with some more negative terms. Anyway, we're almost done. Add 1 to both sides. You get 3x equals 21. Divide both sides by 3. X has to be 7. And I can check my answer in the exact same way I did before. I can plug 7 in there. 5 times 7 minus 1 is 34. Plug 7 in there. 7 plus 10 times 2 is 34. So 34 equals 34. And we got the answer. So there you go. We have finished our problem set. Now, again, if you watched, I hope you watched the first video where I went over how to scan and stuff. So if not, just go watch that video. So I'm going to go to my Adobe Scan app. I'm going to scan this. It'll show up in my document cloud, Adobe Document Cloud. Just download it locally to your computer and then attach the file in Classroom to submit it. I'm sure some of us are going to have some trouble the first time doing it. It's totally fine. If you could just email me, let me know you're having trouble figuring it out. I can help walk you through it. And also, I mean, if you have another way to scan to PDF that you've used before, that's fine. You don't have to use my way. I just need you to submit a PDF scan of the assignments. Or I think I said this earlier, but when we're going, assuming the school is still open and all that good stuff, if you want to pick up your problem sets, do all the work on them, and then bring them back to the school and drop them off, that is also totally fine. But I need to make sure that you all know how to do this just in case we don't have that option. So I need to make sure that everyone understands the process of turning this piece of paper into an electronic format. So, okay, again, reach out to me if you are stuck or if you just have math questions on any of this stuff. And yeah, so starting next week, we'll start getting into some the material of the class, the geometry material. So, all right, that's it for this video.